Okay, so today we're going to demonstrate using a Model 901 to test the oxygen content of a Tedlar bag. We frequently get this question because customers want to check the oxygen content in, let's say, a large cocoon or a large storage bin of some kind. And we can demonstrate here how we can set up a permanent valve on such a container, test from that container without violating the sample inside the container. So we're going to start with a Model 901 that's at 20.9%. This Tedlar bag, currently the valve is closed, so air cannot enter or exit. It also has a resealable septa on the top, but we're going to ignore that for now. We also have two check valves coming off of the valve on the bag, and then a double orange needle that we can connect to with the instrument. So what we're going to do first is we're going to connect the double orange valve to the end of the sample probe. And as you can see, we're in ambient air, 20.9%. And then what we're going to do is we're going to open the valve. And we open the valve by turning the top exactly halfway. So by turning it halfway, the mark is now on the other side of the valve, and the valve is open. Now the critical thing to note here is that these check valves will only allow flow into the instrument. This is important because we do not want anything being able to enter back into this chamber even after we've disconnected from it. So let's press the pump button. We should get about 2.0 or 2.1% out of this bag, and let's give it a try. Now you will hear a slight whistle. That whistle is normal. That whistle is the sound that the check valves make when sample is flowing through them. And so as you can see, we are approaching about 2%. And it takes about 17 seconds or 18 seconds to achieve final reading. Some companies quote the spec as T95, which means 95% of your final reading. We like to quote the final reading as being about 18 or 19 seconds. So it looks like the reading has stabilized at 2.2, which is good. And so that looks like that's going to be our final reading. Now, the important aspect to this is the valve. And what I'm going to do is close the valve now and show you, the other way. The valve is fully closed. So, if we disconnect the instrument, not only is the valve closed, but the check valves would not allow us to put anything into the chamber or the bag. So I'm going to do one last thing just to demonstrate that this type of valve is something that can easily be installed. We've had customers install this valve on containers of olive oil, giant cocoons where crops are stored. And if you take a look, this valve actually comes apart. It comes with the Tedlar bag. And so if you were able to create a hole in your chamber, say you had a large vat of olive oil and you created a hole that was about, that looks about 3/8 of an inch diameter, you can create a valve that you can permanently install on your vat or your chamber. And then, instead of puncturing or violating your chamber every time you needed to sample it, you could simply draw sample out through this check valve and into the instrument. So this would be a good way to have a permanent installation that you can test from without allowing any contamination, because this check valve will only flow in this direction. so nothing will get inside your chamber. And so that's how we can set up a permanent installation for testing oxygen on a chamber.